In the coolest store in the world with all of your favorite stuff. I mean, we have got the ping pong ball pistol, and we've got cupcakes. What are these called?
Buttercream.
Buttercreams. We've got moon pies. We even have a crocodile whistle. What are you going to do? You say, I want it all. Well, of course you do. You're an insatiable consumer. But there's a problem. The problem is you've only got so much money to spend, and this stuff ain't free. You're going to have to pay $3 to get the punching monkey. You're going to have to pay $1 for a package of circus peanuts. How are you going to spend your limited budget when you have to choose between Krispy Kremes and Squeaky Nuns? Well, it's tough. So we're going to help you by introducing some economic tools that we use to describe consumer choice. The first set of tools describe what's possible or feasible. These are the tools that describe the amount of money you've got to spend and the combinations of toys and snacks that you can afford on your limited budget. That is, we're going to start with what we call the budget constraints. Then we're going to move to a representation of your preferences. That is, how you would make trade-offs between Bunny Bowl and snacks. That is, we will come up with a set of indifference curves that represent your preferences for toys and snacks. Then we'll put the curves together with the constraints. We'll put what you want together with what you can get and come up with a prediction of how you'll shop. That is, we're going to derive a demand curve and show how you respond when you're given a set of constraints and a set of opportunities. And we'll use that to connect it with a tool, the demand curve, that you're already familiar with. So let's get started. The first thing we're going to do is clear away these infinite possibilities and focus on what's feasible for you, given the constraint of your income and the price of the products that you want to buy. So let me do that. Make a little space here to do a little rigorous math work. And the first thing we're going to do is derive a budget constraint. So let me put some axes here in my picture. Whenever you're doing consumer choice, you're going to be drawing graphs that we describe as goods space. Goods space means you're measuring quantities of goods on each of the two axes. So on the vertical axis, we're going to measure snacks. And on the horizontal axis, we're going to measure toys. And this is how you make your trade-off between toys and snacks, is you choose a point in this space. For example, this point here might represent 2 toys and 2 snacks, and this point here might represent 12 toys and 4 snacks. Sorry, I'm wrong, aren't I? 12 snacks and 4 toys. So you've got to be careful. The horizontal coordinate tells you how many toys you've got, and the vertical coordinate tells you how many snacks you've got. Now that we've got this picture of goods space, we're going to use it to represent your budget constraint. That is, what are all of the combinations of snacks and toys that you can afford to purchase given your limited income? Well, if you want to put together a budget constraint, you're going to need some information. The first piece of information you need is how much money do you have to spend in this store. Let's suppose you have $12 to spend. $12 to spend on whatever combination of snacks and toys you choose to purchase. The second piece of information that you're going to need is the price of a toy. And let's say that toys are selling for $3 a piece. So the price of a toy is $3. Let's say that the price of a snack is $1. That's the third piece of information you need. How much does a snack cost? Well, now that you've got these 3 pieces of information, your total income or budget, your price of a snack, and your price of a toy, you can describe all of those combinations of toys and snacks that you can afford to purchase. I like to start by finding the endpoints on my budget constraint. Suppose you spend all of your income on snacks. How many snacks will you be able to buy? Well, you have $12 worth of income, and snacks cost $1 a piece, and that's going to give us a total snack purchasing power of 12 snacks. If you converted all of your income into snacks, you could buy 12 snacks. Now let's suppose instead you bought only toys. How many toys could you afford? Well, with a budget of $12 and a price per toy of $3, then you can afford to buy 12 divided by 3 equals 4 toys. So the endpoints are 12 snacks and 4 toys. Now, what about combinations that have some of each in them? Let's suppose you decided you wanted to buy 2 toys. How many snacks could you afford to buy? Well, 2 toys will cost you 2 times $3 equals $6. Subtract 6 from 12, that leaves you $6 to spend on snacks. And since snacks are $1 a piece, you can afford to buy 6 of them. So 1 point on your budget constraint will be 2 toys and 2 for 6 snacks for a point like this. Let's calculate another point on the budget constraint. Suppose now you only buy 1 toy. How many snacks can you afford to buy? You calculate it. One toy costs $3. Subtract $3 from your budget of $12, that leaves $9 to spend on snacks. And since snacks cost $1 each, you can afford to buy 9 snacks. Another point on the budget constraint. One more point. Suppose you buy 3 toys. How many snacks can you afford to purchase? With 3 toys, you can afford to buy 3 snacks. 3 toys cost you 3 times $3 is $9, subtracted from 12 leaves you $3 for snacks, and since snacks are $1 a piece, you can afford then 3 snacks. If we kept doing this, we would be generating more and more combinations of toys and snacks that you can afford, given their prices and given your $12 worth of income. Eventually, when we connect these dots, we will get the budget constraint. The budget constraint will be the point. The budget constraint is the collection of points that shows all the combinations of toys and snacks that the consumer can afford to purchase given their fixed income and the prices of the goods. That is, all of these points along this line represent feasible combinations of toys and snacks. Combinations of toys and snacks that you can afford. The way to represent this line is to manipulate the budget constraint. Let's write the budget constraint down and then let's change it algebraically. The budget constraint says that the income that you have to spend, M, will be equal to the price of toys multiplied by the number of toys that you buy, plus the price of snacks multiplied by the number of snacks that you buy. Well, since snacks are on the vertical axis, we want to isolate our snack variable in terms of all the other variables. The first thing that we'll do is we'll move toys to the other side of the equation. M minus the spending that you do on toys is equal to the amount of money that's left to spend on snacks. Now, divide both sides of this equation by the price of snacks, and I'm also going to move snacks to the other side of the equal sign, and I get this. The total number of snacks that I can afford to buy is equal to my income divided by the price of snacks minus the price of toys divided by the price of snacks multiplied by the number of toys that I buy. This equation that I've drawn is the equation that I've graphed here in goods space. This is the equation for this line, which is the budget constraint. The way to understand this equation is this. The total number of snacks that you're able to afford is equal to what you would be able to afford if you spent your entire income on snacks. That is 12 divided by the price of snacks of $1 for a total of 12 snacks, minus the number of toys that you buy multiplied by the relative price of toys and snacks. That is, since toys are $3 a piece and snacks are only $1 a piece, each toy that you purchase is going to cost you 3 snacks. You have to give up 3 snacks to get each toy. The negative sign lets you know that the line is downward sloping. But this relative price term, the price of toys divided by the price of snacks, is important because it's the opportunity cost of getting another toy. The opportunity cost of buying another toy is this number right here, or the 3 snacks that you have to give up to get that toy.